All right, from last week, just a few things that I noticed as I was going through and grading everything. One of the big things was the definition of a function, and I wanted you to write it in your own words, but just to make sure that we're all on track. In order to be a function, what we're talking about is some sort of relation or a set of ordered pairs where every input, or you could say x value, goes to exactly one output. Okay, so you have to have something about saying that it goes to exactly one output. And then when it says example and a non-example, so you were supposed to give one of each, and I think it's easiest kind of just draw a picture. Most of you guys got this one, but again, just to make sure, this would be something that is considered a function because it passes the vertical line test. Every input, which is represented by a red line, has one output, which is represented where it touches the graph. Now, something like a circle, which I saw a few of you guys did, this would not be, because as soon as you draw that vertical line, which is our input, you can see it has two outputs. It crosses the graph twice. Okay, so I just wanted to be clear on that. And then the next thing was when you were looking at sequences, there's a difference in our notation between f of x equals 2x and g of x equals 2x versus the stuff with the n. The stuff with the n is a sequence, and those sequences only have a domain, which is the inputs, of whole numbers, like nothing in between. Often when we make a table, we'll put whole numbers in here for our function, but we can actually plug in any number from negative infinity to infinity for both this one, for this 2x function, which is a line, and also for this function. So I just wanted to be clear on that. And so what that means is that your graph for this guy would have been at some sort of line like that, and your graph for this guy would have looked something like this. So it's like a connected continuous line, compared to our sequences would have just been dots. So again, just making sure we're clear on that. So we have these dots. That's all it is. Don't connect them. And then similarly over here, we have a 2, 4, and then this one's kind of off the chart. But again, do not connect the dots for our sequences. And you know they're sequences because of this notation here. All right, the other thing I wanted to share was a lot of people skipped graphing this, and I'm not quite sure, but I just want to make sure that we do know how to graph it. So this is a linear function, and so linear functions are when you have like a x with no power that you see, so it's just power of 1. So really it's in this form, y equals mx plus b. The m is your slope, which really we're talking about the rise over the run of your line. The b is the y-intercept. That's where you cross the y-axis. So for this particular problem, my y-intercept is 3, so this is where I'm going to start. So my y-axis is the vertical one, so I'm starting at 3. Now my slope is this negative 2/5, so that's my rise over my run. So that's how I'm going to move. So m, you can think for movement. So I'm going to go down 2 spaces, that's the negative 2, and then to the right 5 spaces, and that gets me another point on my graph. And so this right here would be the graph that's expected. Now a couple people did skip the constant function. This one's just telling me my outputs are 5 all the time. So I'm going to start by putting my y-intercept there, but if the outputs are 5 all the time, you have this horizontal line. So again, just wanted to show you the difference between those two. And then the last thing that a few people are having some trouble with was our check-in. And so for the check-in, all I wanted you to do was just a quick sketch of these 3 graphs. So basically from memory. So if you did the UCLA Palms activity and you've done all of your note pages for graphing functions, then you should be able to do these from memory. That means don't make a table. So all I need to do is say, okay, for number 1, I know it's going to be something that's on a graph. Number 3. And so really quickly, I know x squared is a parabola at 0, 0, so I'm just going to make this little U shape. X cubed goes through 0, 0 also. 1, 1, -1, -1, and so it's this kind of snake-looking thing. And then number 3, that's the square root function. I can't plug in anything negative, so it starts at 0, 0, 1, 1, and then it shoots off. So those are my graphs. This is x squared, the quadratic, x cubed, that's a cubic, and then this is the square root function. Now, if you can't do those from memory, that means you need to practice these, because we're going to get into more detail with these. We're going to do these things called transformations after our exam this week. So please make sure that you know all of your basic parent functions. So in addition to these guys, you should also know, let's put a few more on here. You should know the cubed root of x, which looks like kind of the opposite of the cubic. It's kind of laying downward. It's not growing as fast. You should also know the reciprocal function, which is the 2 parts, because we cannot plug in 0, otherwise we're undefined. So it's got these 2 little sections to it. You should also know the identity function, which is just the x. And again, it's 0, 0, 1, 1, negative 1, negative 1, and then you just sketch your line there. All right, and we also have the constant function, which we just saw, which is when you just have some number. So if we just have like f of x equals 3, we know that it's going to be a horizontal line through 3. And then we also have the absolute value function, which is going to be our v. So those are the main functions that you should know and be able to just, once you see the equation for it, you should know what the graph looks like. So hope that was helpful. Hope you're having a good week.